This conference will now be recorded.
Okay. Okay, sir. So just a second, I'll say this values. Okay, so I started my screen sharing. Is that visible? And I hope my voice is clear. If you have any issues in my voice or if my screen is not visible, please post me a message so that I can stop and then I can rectify it and I can start taking. Yes, guys. So good morning once again. So yesterday we started with insertion and deletion. So yesterday we started to create this. So inserted last, inserted first, and inserted specific question. And also I have shared the logic for how to delete a node. So today we can complete all these functions. Before deleting, so we have to see one more function. So there is a display function. So we'll be explaining what is this display, how the display works. After that, I'll be explaining all these three delete functions. So deleted first. So yesterday I also converted that deleted first, completely deleted first and deleted last. But I'll be explaining with the code today, and also I'll be explaining with this delete specific element or delete a specific position. So we can see for that functions, and after that we try to solve all the problems in this module. So I hope everyone has started to work on this module. So we also will be start to work and we try to solve as much problems as we can. Because these are the same problems that we are going to work right now. So that will not be an issue. Yes. So okay. So and yes. So before entering into the actual coding session, just I want to uh, refresh you guys. So like, what are the types of linked list are there? Types of linked lists. So now what we are seeing is only single linked list. Single linked list. Yes. So there are still two, three more types. One is double linked list, or it will be called as DLL or doubly linked list. So doubly linked list. And then we have third type. Third type is nothing but circular list. Yes. In circular list, again, we have two different types. One is single circular list or doubly circular list. So these are the four types of linked list that is available. So I mean, in general, I'm just giving it as a circular list. Circular list. So this has two types: singly circular list or doubly circular list. So now these two types. So I don't want to give it as a separate thing, but it's more common. And what you guys want to know is, as I said earlier, in Java and Python, all these functions, the functions that we are writing right now, that is insert at beginning, insert at last, insert at middle position, or insert at specific position, or insert at index, or what are the functions that we are going to write is already available in Java and Python. But what type of linked list they use, that is the thing that we want to know. So mostly Java and Python will always go with this doubly linked list. either with doubly linked list or circular double list. Doubly circular list. So they will not be mostly using the single linked list. They will be always using this doubly linked list implementation or doubly circular list implementation. Right? So then what is there in doubly linked list, sir? So what is the difference between single linked list and what is the difference between double linked list? So in single linked list, what we have? We have one node. Yes, correct. Yes. Yes, we have one node and that node is connected to my next node. So that is the only way that I can connect to my next node. Correct? Correct. Super. Yes. We can have the previous node's address and also we can traverse in both the sides. Correct. Good. Super. So in single linked list, what we have is we have just only one thing. One is our node, the structure node, which has the data part, After that, we have only one link that will be present next to me. So that is going to be structure node star next. So this is what we call this as a single linked list. Correct. But in double linked list, so this is an example structure node for single linked list. But in double linked list, what happens is he will keep track of my previous node. As we said yesterday, so in deletion process, we keep on tracking my previous node. So that only I can delete this node's address from my previous node. So that is the extra previous uh, address variable that we are going to create to make my process easy. Yes. So that is the key point where we started to use my double linked list. That is the where so not only for deletion, for other process also we may use this previous node, or we can either keep this track of this previous node. So that is the point where this double linked list start to evolve from single linked list. Can you guys understand this? So double linked list. So the structure it has only extra one node. So the same structure node with the same data part. The data part can be anything. Data part can be converted to anything. So here he has two address references. One is structure node. One will refer to my previous node. Another one will refer to my next. So by using this variable, we can keep track of my who's before me and who's next to me. So that is the only extra variable that is added in my node structure. Okay, it's doubly linked list. Yeah. Okay, Dhanush, I can't understand the question correctly. What is the previous and next?
Sir, he's trying to say that there will be two pointers, pre and next, I think so.
Oh, 2 pointers. Yes. Okay.
Yes, Dhanush, am I right?
Okay. Okay. So yes, so we can keep track of the previous pointing by using this previous node. Okay, so this is the extra one variable that will be added to my node, which will keep track of my previous node. So you will understand it better when we start to solve the delete node. So actually yesterday we started with delete process node. So we start to complete that process so that we can understand it clearly. So how this previous is going to help with me to solve my problems very easily. Yes. So this I want to give an intro about this W linked list. What is this? So what is it extra it has and what will happen? That's it. So just we move on to the function implementation and then we start to understand this previous node in a better way. Yes. So just for right now, we just know only one thing. In a W linked list, we have the same set of structure with extra one variable. This variable which will keep track of my previous node. Maybe I can show with an example. So for example, till now we have a head 10x. So this is going to be my first node. And so just I'm giving a single linked list example. So this is a single linked list will be there. So 10 will be my data, 20x will be my next data. And after that, I will have 30, 30x and 30 will be my data. And there's no next node. So this is a normal linked list. If it is going to be a doubling linked list, if it is going to be a doubling linked list, then it will have two address variables. One is each node will have a previous node and also a next node. So for node 10, so this is node 10. I hope my screen is visible and you are able to see this list which I have created here in the last bottom of line. Yes. So what happens is I will be not only having this next node, I will also have a previous node. I will also have a previous node. So is there any previous node for my head node? Is there any previous node available for my head node? Because head is going to be my starting node. Is there any previous node there? So there is no previous node there. So the previous will be null. There is no null address. And 20, who is going to be my previous node for my 20? Who is the previous node for my 20? 10x. So 10x will be stored inside my node 20. So it will be like previous node, data part, and my next node. So similarly for 30, 30 is the node which will have a previous node. The previous node address will be 20x. So this is the extra part that will be added in a W linked list. Yes. Do you guys understand this? What is a W linked list? So later when you implement this, you can understand it better. But for your understanding, I want to give you an example how this W linked list look like. Can you able to understand this W linked list? And whenever you're going for Java and Python and implementation of collections using list or set, everything will use only a W linked list. They will not be using single linked list. They will always use only the W linked list. And either it can be a W linked list or it can be a circular W linked list. So circular list is nothing but that. So later I can explain that circular list. Circular list is nothing but just giving the first node address to my last node and last node address to my first node. That is the only thing that will happen in my circular list. So later we can see this. But up to this, is everyone clear what is W linked list and what is the extra part that is added in my W linked list? Guys, up to this, is everyone clear what is W linked list and what are the things that are available inside my W linked list? Yes, guys. So now I'm moving back to my implementation part. So first we start with display function. So will we complete all these functions, all the 6 functions, 7 functions in a single program? After that, we try to solve the problems in EdMatrix platform so that we can understand it clearly. Okay, so first is display function. So just I'm taking the already existing program. So we started with this display. So what I'm going to do is I'm just going to display my entire list that is available I'm going to just display all the nodes that are present inside my nucleus. Okay, sir. Sir, first thing first, sir. Up to this, we always use this head address. We always use this head address, but whenever I'm coming to display function, I'm not going to use this head address. What is the reason, sir? Even for deletion or insertion, you have started to use the address of my head. Address of my head. But whenever I'm displaying or whenever I'm writing a function called display, I didn't write any head address. I doesn't get any head address. I directly send the head's value and I can directly access that value. So why, sir? Why this happens, sir? Very good. Yes. Yes. I got an answer. It's from Sriram. So we're just accessing the value to store. That's it. Yes, sir. So just keep understand one thing. Whenever I'm going to insert or whenever I'm going to delete, whenever I'm going to insert or whenever I'm going to delete, there is a possible way that I can change the value inside my head. Correct? Maybe I can insert a new node at first position or insert at head, or I may be deleting the node at head. So there is a possible way only where the head value can be changed. So for that reason alone, the changes that is going to happen in my first node alone, whenever I'm going to update the value in my head, for that reason alone, we'll be getting the address of my head. Address of my head. For the rest, any operations, if there is no change is going to happen in my head, sir, head value doesn't change, sir. It will always remain the same. I'm not going to delete or I'm not going to insert new node in my head. So then at that time, it doesn't want the address of my head. We can directly use the value of the head. Yes. Yes, yes. So that is the only reason why we are using for insertion and deletion, we are using this address of set. And in display function, in display, am I going to insert a new node in display? Am I going to insert a new node into my linked list? Yes, someone guys. Okay. Sorry, guys. Okay, so that is the reason. So in display function, yes, correct, correct, correct. That is the reason you are not using the address of state here. Just I need the starting address of my list. Then I can iterate through my entire list and I can just display the value. That is fine for me. I'm not going to insert. I'm not going to delete. I'm not going to update any values. Correct? So even updation doesn't want to change the value because updation is going to just change the value. He doesn't want to change the address of the head. So please keep that in mind, guys. Whenever you are writing a function, then think that if I'm going to insert a new data to my list or delete a new data or delete a node from my list, in for these two operations alone, we'll be requiring the head's address. We'll be requiring the head's address. For the rest, any operations, we doesn't want the address of my head. Yes, and I hope you understand the seriousness of these two operations because adding an element to my data and removing a data from my list is going to be a sensitive issue. So that is the reason why we are not using this global variable declarations. So whoever I'm going to send the data, I'm the one who's going to send the address where you have to start. Yes, so that is the reason why I'm not using any global declarations, because data is going to be very important and it should be prepared correctly. So that is the reason why we are not using any global declarations. I'm using this type of implementation. Is it clear, guys? Is it clear? Yes. Okay. So right now I'm starting the function here. Yes. I'm just taking a simple example, the same example. So head of 10x. So head was the first node 10x, and 10's next node is going to be 20x. So I'm just going back to my single linked list. I'm not going for my double linked list. And 30x and 30. 30's next node is going to be 40x, and 40's next node is null. So this is a simple example I have taken. So whether you can able to understand this node, whether you are able to understand this linked list, just I have given a simple linked list. So 10x is the starting address. So head holds the starting address of my list, and 10 is my first node. The first node has two things. One is 10 as my data, and 20x as my next data. Is it clear, guys? Is this example clear, or do I want to use Excel? Can you able to understand this, or do I want to show it in a diagrammatic way? Yes. Okay. Okay, sir. So now I'm just doing that. I'll be explaining it clearly just by complete this function, and then I will explain it. Okay, so this is the function. This is a display function. So this is going to be my display function, and I'll be calling my main function. I'll be calling this display function from my main function. So here, what are things that are available? So what I'm going to do is I'm having one is head. So head will hold the starting address. It is going to be 10x. So that is the thing that will be there. So from my main function, I'll be calling this function display. So display of head. So I'm not sending the address of my head. Please keep this clear. I'm just sending the head value, not the address of head. So what happens is, so whenever, okay, just give me one suggestion. Either I can use a variable name head as it is, or I can change the name as different, temp or something. Can I use a different name? Because head is already there. Can I use it as a different variable name? Yes, I can change this. Just I'm changing this. Yes, so that we can understand it clearly. Okay, oh, that's fine. So now what happens is, so from my main function, so inside my main function, I'm calling this display function. So in this display, what I'm going to do is I'm just passing the value of my head. So what is the value present inside my head? What is the value that is present inside my head? What is the value that is present inside my head? It's 10x. 10x is nothing but 10x is a what is its type? What is its type? So first thing first, I'm from here I'm sending a value here. To store that value, I want a variable. So for that, I have created a variable called temp. So inside my display function, I have created a variable called temp. So now I want to define the type of my temp. So what is the type of my temp? So what is the value that I'm getting from my head? It is going to be a what value? Either it is an integer, whether it is a float, whether it is a character, or whether it is a address, or whether it is a single value or a double value. What is it? Guys, I don't know whether it's my voice is clear or is it clear or not. But yesterday I was getting so many responses, but today I'm getting only 2 to 3% responses repeatedly. What about the rest? Do you feel very bored? Sir, this session is very bored, sir. Boring, sir. Or sir, this session is not understandable. Yes, because the thing that I'm asking right now is very easy for you because you already solved all these problems. So just I want to understand this whether you are able to follow me or not. Because if you reply only, then only I am unable to understand that yes, you are following me. Yes, thank you. So only 5% are listening and they're able to respond. Yes. Okay, so now you guys tell me. So now tell me, what is the value that is I'm going to get for this step? From my main function, I'm sending the starting address of my head, correct? So what is the value that will be stored in my tab? From here, I'm sending the starting address. So what will be the value that will be stored in my address, correct? So I'm going to create a variable term which is going to store the address of my first node. So that is the reason I have given pointer. Pointer which represents that I'm going to use a variable temp which is going to store an address. Correct? Whenever I'm telling that it is going to be an address, then I also tell the compiler that what type of address it is going to store. Correct? So 10x is going to represent whose address? First node's address. Correct. First node's address. So that is the reason I have given the type as structure node star. So many may get a doubt like this, sir, why I'm not using like this? Why I'm using as a single star? So this is the reason. We are not sending the address of my head. We are just sending the value inside that head. So that is the only reason why we are using as start there. Can you able to understand this? Why I have given like this? Structure node started. So temp will get the value of first node's address. So variable temp will hold the value as 10x. So the type of my 10x is going to be an address. So I'm just creating it as a pointer variable. And who's going to point? It is going to point the first node. So I'm giving the type as my structured node. Up to this, is everyone clear? So why we are given as a structured node started? Yes. So now you are going to start the operation. So what is the operation that I'm going to do here is I'm just going to iterate through all the list nodes, all the nodes, and I'm just going to display the value inside my node. So that is the process I'm going to do. So that is the reason I have given the name as display function. So you can keep the name as anything, either read, write, or display in a function or display whatever the function that you are think that is a valid name, then you can keep it. But right now I'm just giving it as a display function. Okay, sir. So first things first, I'm checking whether a list is available or not. So how can I check that list is available or not? If there is no list has been formed, then it will have what value? It will have null value. So the same value I'm using here. So instead of using head, the value of that head is transferred to this variable temp. So instead of using head, what I'm going to use, I'm just using the temp value. Correct? I'm checking whether my temp is null or not. If it is null, then what we can tell that if it is null, then there's no list has been formed, the list is empty. I cannot iterate it. Correct? There is no list has been formed, so I cannot iterate. So this I can print it as list is empty and I can return back to my previous move. Okay, sir. So in our example, so 10 has a value as 10x. So now 10x is equal to null. Condition becomes false. So it states that there is a list available. So I'll be moving into my loop. Okay, sir. So now first I'm coming into my loop. Coming to my else part. So now what I'm doing. So what is the process I have to do? I have to go and visit each and every node. Correct? I have to visit each and every node. So if it is going to be an array, if it is going to be an array, so we normally use what we will be using for int I equal to 0, I less than n, and then I plus plus. So this will, so we will be just displaying. So printf percentage d, comma, arr fine. Yes, I hope you all understand this. You all know this. What is this? You all know what is this. Just iterating through my entire array and I'm just going to print it. Sir, what is this I equal to 0, sir? In array. I'm not using in linked list, just in array. What is this I equal to 0? So I is nothing but my index, first index or the starting index, correct? Where it is going to start, correct? So instead of this, what we have here is we have this temp value. This temp is going to hold the starting address. Okay, sir. So then what is this, sir? Second one. I is less than n. That is a condition. Yes. What is that condition tells us? traversing till the end. Correct. But here we have a value here. Sir, this is the maximum capacity of my array. So this is the maximum value that index can be. Like that I'm telling it. Correct? Sir, yes or no, sir? Sir, my array can hold only 10 values. So the maximum index can be of 9. Correct? So that is the n value. So n is going to be a 10, 20, 30, 40, 50, 60 like that. Yes or no, sir? Yes. So whether I have any static size for this linked list, or I can represent, sir, this is the number of nodes present inside my list. Is there any way that I can identify that? No, because whenever a new node comes, I'm automatically adding to my last of my node or a first of my node or physics question. So there is no limit for my list. So I cannot keep count of how many nodes are there in my list. Correct? So then how can I traverse to all the nodes, sir? Then how do I know that these many nodes are there? Then how can I traverse to this last node, up to this last node? Very good. Very good. Until we reach the null pointer. So we know only one thing, that is the last node's next part. The last node's next part is always going to be null. If it is not null, which represents that there is a next node available, then I have to move to my next node. If there is a next node available, if it is not null, then it states that there is a next node available, then I have to traverse to my next node. So that is the part that we are using here. So we directly can't use this. I use resilient. So instead of what we are going to use is we are checking for this null value, whether I have reached the null or not. If I reach the null, then no issues. The list is over. Then I can move. If it is not null, if it is not null means then what it says that there is a next node available. So that I have to move to my next node. I have to print the data of that node and then I have to move to my next node. So that is the condition that we are using right here. Yes, so that is the reason. So many can ask me question, sir, why sir you are not using like this? Temp equal to null. Whether it's the correct solution, whether it's the correct condition. If anyone have any doubt like this, sir, why you are using temp is not equal to null? Why you are not using like temp is equal to null? Yes. So what happens is if I have 2 to 3 nodes, then for example, if I check the first value for my 10x is equal to null, at that time itself my condition gets false because 10x is not equal to null. Correct. I'm checking the condition as 10x is equal to null. So it will not go to my next node. So that is the reason why we are not using this equal to null condition in my linked list implementation. So mostly we'll be checking with only not equal to null because we doesn't know what is the address value is going to be. We know only one thing is the last node and next node will be a null value. So that is the reason we are using this not equal to, because if we know the exact value, we can directly give the exact conditions. But here the address may be anything. So here it can be of, so for example, I have given as a 28, 38, 48, but the system may take it as a different banner. So it can represent it as a zero. Actually, as we have seen, no. So it is starting with 00CCS1. So the address can be of any time. So we doesn't know the exact value how it is going to be. So if for only which you know this address is going to be like this, then I can directly give it in a range. Like this is the starting point and this is the beginning point. So I can do it. But that it's too much of time. So to simplify that, we directly use this next node's null value. So that is the reason why we are using here are not equal to condition. Yes, guys, this not equal to null is one of the condition that was asked in technical HR. In technical HR, one HR, as you have seen here, why we are using not equal condition here? Why we are not using equal condition or double equals condition here? This was a question that was asked in technical HR. Please make a note of it and please understand it clearly. Yes. Okay, sir. So now we have solved this condition. So now we have solved this condition. So what is this I plus plus? Increment. So increment means go to the next question. Yes, sir. So in link plus, how can I move to my next question? That's it. So I have to move from a current node to current node's next part. So there is a condition here. So this is my increment part. Temp equal to temp of next is my incrementation part. Yes, sir. The same step which we are going to use. And after that, I'm printing the value. What is the value that I'm going to print? The value inside that specific index. Correct? To print the value at the specific index. So I'm not going to use any index here. So instead of that, what I'm having is the address of my node. So I can directly take the data part of that node and I can print it. Correct? So that is the thing that we are using here. So temp of data will take the data part and print it. Yes? Okay, so this is how we are just splitting our loop, for loop into a while loop or converting its while loop. I hope you understand it clearly right now. Is it clear? So how why we are using this while, why we are using this print, and why we are using this temp equal to temp of next? Is that clear? Yes, I got a question. So Disha, sir, what is the difference between temp is not equal to null and temp of next is not equal to null? Very good question. I will explain you within a second. Before explaining that, I'll be iterating through this solution. Okay, so printf. Okay, okay. Disha, I'll be explaining you after solving this. After that, I'll be explaining you what is the difference between this temp is not equal null and temp of next is not equal null. Yes. So before that, okay, sir. So, sir, what is this printf, sir? Printf. Okay. So, as I said, so we started with this for I equal to 0, I less than n, and then I plus plus. So after that, what the operation that I'm going to do is in array, I'm just going to printf. So printf percentage %d, comma, ARR of I. If so, this is the process that we are going to do in an array, normal array. So if I want to display the value inside array, I'll be printing the value inside that array. Correct? How I'll be printing it? I'll be using this variable type, that is format specifier, followed by the value that is going to be printed. Correct? So how I'm going to take the value? I'm just going to take the value by using that index. But here in linked list, do I have any index here? In linked list, does I have any index here? No, I don't have any index. So then how can I take the data part, sir? Because data is the part which is going to hold all the data. Correct. I have only pointers. So then how can I access this data, sir? I have the address, correct? So this address holds two values. One is data part, another one is next part. Correct? Yes. So by using this address of data, so this will get the data inside that address. So that is the thing that we are doing here. So temp will hold the address of my data, sorry, address of my node, and by using that address, I'm going to take the data from my node. Yes. So instead of using ARR of 5, what we're using is we are using this arrow operator to take the value inside this data part. I hope now it is clear. What is this printf statement? Yes, sir. So now I'll be explaining it. So we'll be explaining it from start. So, yes, sir. So now the temp is going to be 10x. Yes, sir. Now I'm coming here. I'm just starting the loop. Starting the loop. I'm checking whether 10x is null. 10x is null, whether 10x is not equal to null. 10x, the condition will be like this. So I'm checking the condition is 10x is not equal to null. What will be the result? Either true or false. 10x is not equal to null. Yes, condition true, which states that what it says. We have not reached the last node. There is a next node available. So I have to print the data and I have to move to my next node. So that is the explanation for this. Correct? If it is not equal to null, then what it says that there is a node available there. Then I have to print the value inside that node. Then after printing it, I have to move to my next node. Yes, that is the explanation for this statement. So if it is null, then what it says that we have reached the end of the node. So now what happens is, so now 10x is not equal to null, which says that there is a next node available. There is a next node available. So now I'm entering into my loop. So what happens is, I'm just taking the value from my 10x. So temp will give the value of. So now what happens is, temp will give the value of 10x. And from 10x, I'm just going to take only one thing. What is the data part? Correct? So what is 10x data? So 10x data. Yes, 10x data is going to be 10. So what I'm going to do with the 10? I'm just going to print the value with the comma specifier. That's it. I'm just using an arrow operator to just mention it. So first time, what I'll be doing is, I'll be printing the value 10 with an arrow operator. See, arrow is just an operator that I have given to represent it. That's it. If you want, you can use it. If you don't want, you can just skip it. So now I have printed the first data in my list. So I have just printed the first data in my list. So now what I have to do? I have to move to my next one. Correct? So now I have to increment my temp from 10x to 20x. So how I'm going to do is, I'm just pointing my temp to my new address. So that is nothing but, so at this point, my temp has value as 10x. So 10x next part. So 10x next part is what? 10x next part is 20x, correct. So 10x next part is 20x. So now the 20x will be updated in my temp value. So now the temp has got updated, correct? Now the temp has been got updated. So now again the loop starts. So now temp holds the value of 20x. So now I'm checking the condition whether 20x is not equal to null. 20x is not equal to null or 20x is equal to null. So 28 is not equal. Condition 2, it states that you have not reached the end of my list. It states that there is a node available, so I have to go and visit that node. So now I'm coming into my loop. So I'm checking. So now the temp has the value of 28. So 28 data. What is this 28 data? 28 data is going to be 20. I'll be printing the 20. After printing the value, what I'm doing is, I'm just updating the value of my temp. So now what I'm going to do is, I'm just updating my value from 20x to 20x next part. So what is 20x next part? Twenty-x next part. 30x, correct? So now I'm updating this third temp with 30x. Yes. Now again, my updation has occurred. So now the loop will continue. So now the temp will have the value of 30x. 30x is not equal to null. Condition again becomes true, which states that there is a node available. There is a 30x node is available. So I have to visit the 30x node. So now what I'm going to do is, I'm just going to visit the 30x data. So what is the data inside my 30x? What is the data inside my 30x? It's going to be 30. First, I'm printing the value. After that, I'm updating my 10. So now what I'm doing is I'm just incrementing my index from 20x to 30x next part. 30x next part is nothing but 40x. Yes. Again, temp has been updated. Now again the loop will start. So now I'm checking with the condition. Whether, so what is the value inside my temp? So value inside my temp is going to be 40x. Whether 40x is null or not. I'm not checking 40x next part. I'm just checking whether 40x is null or not. It's not null. Yes, condition 2. It states that there is a node available there. Correct? 40x is a node that is available. So I have to visit that node. So now what I'm doing is I'm just going and visiting the node. So 40x data part. So 40x data part is going to be 40. And I'm updating my next node. So that is updating my 40x next node to my 10. So now the 10 will be updated as what? What is this 40x next part? For which next part is nothing but null. So now the temp will be updated as null. Yes, sir. Again the loop starts. So now temp holds the value of null. Now what will happen? Null is not equal to null. List is empty. We have reached the end of my list. So my list is empty. So there is no other node to be visited. So condition becomes false, which states that, so as you can see, we have visited all the nodes, starting from my first node to last node. Correct? Starting from my first node 10 to, so 10, 20, 30, 40. We have visited till my last node. We have visited till my last node. Okay, sir. So after this, the loop will break. So whenever the loop breaks, I'm just for our identification, I'm printing it as null. Just for our understanding. It is not for any criteria. It is not like that. It is just for our understanding. I'm printing it as null. If it says that there is no other list is available there. Yes. That's it, sir. So we have visited all the nodes. We have visited each and every node. Correct? Yes, sir. So then, do you understand this? Do you understand these steps? Whether you are clear with this? Is anyone having any doubts in it? Okay, sir. So now I'm coming back to that question. So your friend has asked one question. So the beautiful question. Sir, what is the difference between these? Because still yesterday we have used only this temp of next is not equal to none. Yes, sir. So I'm just going to use the same example. Okay, sir. Okay, sir. Now maybe I can change with the two variables. One is temp, another one is temp1. I can keep this as temp1. Maybe that will be helpful to understand what is happening here. Yes. For both the values, what I'm going to do is I'm just going to assign the starting address. That is going to be my head address. So temp will also hold the head address and temp1 will also hold the head address. Okay, sir. So can you iterate it right now? Can you iterate it? Because whenever we see what is happening here, yes, yes. So your friend has got the answer, but even though I can explain it, but I'll be explaining one more time so that you can understand it clearly, so that you can understand this what is happening here. Correct, Sriram? Yes. Okay, sir. So for both the values, I'm just starting with the head value. So temp is going to hold the starting address, starting nodes address, and temp one is also going to hold the starting address. So now what I'm going to do is just I'm going to iterate it through these two nodes. So first here, what happens is it is starting from 10x is not equal to null. So 10x is not equal to null, which is a condition true. So what happens is I'm moving to my next node. So with moving to my next node in the sense means, so I'm moving from 10x to 20x. So just updating temp from 10x to 20x. So 10x next part. Yes. In the same way here. Here what I'm checking. So here temp1 is nothing but the same starting address 10x. But instead of taking with 10x, what I'm going to do is I'm taking the next part of my temp. So what is this next of temp? Yes, that is going to be 20x. I'm just checking the next node of that current node. So what happens is this will give me a value as 20x is not equal to none. Yes, 20x is not equal to null. So again, the condition is going to be true. So what I'm going to do is same updating. So from 10x, I'm just going to update it to 20x. Correct? So now here it will be updated as, so already my temp one holds the value of 10x. So what I'm doing is I'm just changing the same operation to next part. So now the temp one will be updated as 20x. So now I'm starting with the second iteration. So second iteration, see here. So now the temp holds the value of 20x. I'm checking whether 20x is not equal to null. Yes, 20x is not equal to null. Which says that there is a next node available. So I'm moving to my next node. So there is 20x next part. So temp will be updated as 30x. Now I'm taking with the temp one condition. So now the temp one holds the value of 20x and 20x next part is. I hope you can see the difference here itself. So here I'm checking the current node and here I'm checking whose node. It's next node, correct? Yes. I'm just checking the next node's value, which is in the sense, okay, you can understand and complete this loop. So now I'm checking whether 30x is not equal to null. Yes, the condition is true, 30x is not equal to null. So what I'm doing is I'm just updating the value. I'm just 20x to next. So what happens is 20x of next is going to be 30x. So here the value will get updated as 30x. Again, I'm starting the loop. So 10, so temp is at 30x. So 30x is not equal to null. Yes, 30x is not equal to null. So I'm updating my 30x value. So I'm updating my temp value from 30x to 40x. Okay, sir. So now in my while loop, now my temp one holds the value of 30x. And who's my 30x next part? 30x next part is going to be 40x. So whether 40x is equal to null? No, 40x is not equal to null. So here also I'm just updating my temp one from 30x to 40x. Okay, sir. So up to this, if everyone is clear, there is nothing difficult to understand. I hope so. Yes. So now the actual logic comes here. So now the temp holds the value of 40. Temp 1 holds the value of 40x. So 40x is not equal to null. In the sense, there is a node available there. 40x is a node that is available there. Correct? So now I'm going to update from 40x to 40x next part. So here what happens is, now the temp will be updated from 40x to null. That is, in the sense, I'm visiting the last node. After visiting that, I'm updating the value to my next node. Correct? But what happens here? So here my temp one holds the value of 40x. Now, what is the value for 40x next node? 40x next node. 40x next node will be null. So, and null is not equal to null. What will happen here? So, null is not equal to null. What happens here? Condition false. If the condition false, will I go to this statement? Will I go and look into the statement, or will I update the statement? No, we will not be updating. So now, what is the value that temp one holds? Now you can tell me, what is the temp is holding? What is the temp one is holding? What is the temp is holding? What is the temp one is holding? Yes, temp one is holding the 40x. And what is that 40x? In my linked list, what is that 40x? It is the last one. Yes? Guys? Can you able to understand this difference? It is not only address, it is the address of my last node. Sir, if I want to know the last node's address, who is going to be my last node, then I have to use this temp of next. Sir, I want to know who is the last node, or who is going to be my last previous node. So I can use it. Correct. So I can use to identify my last node, then I'll be using this condition, temp one of next. Sir, I don't want that last node, sir. I'm just going to visit and then I'm going to my next node, sir. So then I can directly use this condition. Temp is not equal to null. I hope understand. I hope I have explained it clearly. You guys can understand it. Correct? No, last node will not be printed because we are checking whether there is a next node is there or not. So this part is mainly used for insertion or deletion, like that part. Okay. So while displaying, we doesn't want to do that insertion or deletion also, because while inserting or deleting, we want this previous node's address. While insertion or deletion, we want the previous node's address. Correct. So then only then I can update the value inside that address. So that is the reason why we are using this temp one of next is not equal to null. Correct. Yes, correct. So your friend Praveen Babu has given a solution, that is a length minus one. That is I is less than n minus one to take the previous node or to take the last node's address. So that is what temp of next. Temp one of next. Yes, I hope I have explained it clearly. Do you guys have any doubt in it? Still no. What is the difference between temp and temp of next? Is not equal to temp is not equal to and temp of next is not equal to none. If I want to access the last node's address, if I want to identify who is my last node, then I'll be using this condition. Temp one of next is not equal to null. Sir, I don't want the last node's address, sir. Just I want to traverse to all the node. Just I want to traverse to all the node, then I can directly use this. Temp is not equal to null. Because I'm not going to do with that address. I'm not going to do any operations. I'm not just going to do anything with, I'm not going to insert, I'm not going to update, I'm not going to delete with the last node. So I don't want that. So then I directly go for temp of next is not equal to null. Sorry, temp is not equal to null. Sir, no, sir. I want to update the last value, or I want to do some changes in my last node. Then I have to use this temp one of next is not equal to null. Yes, guys. So any more doubts in this? Yes, sir. Okay. So okay, it's already 11:30. Um, guys, take 10 minutes break. Take 10 minutes break. We have to complete all the delete functions. So come back by 11:40. See, actually the session is today is late. So take 10 minutes break. So join by 11:40. Come back by 11:40. We can continue and complete the session. Totally. Okay, so good morning, guys. So back again. So shall we continue? Okay. Okay. Yes. So actually, um whenever I'm teaching, you, you think that it is understandable, it is easy to understand, it is easy to understand, or it is very easy like that. But actually, what happens is whenever we're going and see this, or if we take our own example, so for example, instead of using this 10, 20, 30, 40, 50, 60, if you use your own example, and if you write these algorithm and if you iterate it one more time, and you try to solve what is the value that is going to be stored in temp, or what is the value that is going to be stored in temp one, and why it is going to be equal to null, and why it is not going to be not equal to null. If you made these comparisons in your no or in your rough works, then you can understand this in a little more better way. So that is the reason why I'm asking you to post it in a discussion forum so that you can understand it clearly. You can work it out, and you will be tracking these values. See, as you can see there right now, I have given this example as temp and temp one. So where is this temp one starting and where is this temp one is going? So by changing the values for each and every step, we can keep a track of it, and we can understand it clearly. That's it. Yes. So please post the message. Tell your friends to join fast. Okay, still more people have to join, but I don't know. I'm not going to wait for them. Okay, so first, delete at the beginning. So this I'm going to do the same example. So heads, connects, so 10. Guys, just going to move a little bit fast. If you are not able to follow, please post a message or stop me there. So it's a little bit fast and we can go on the way. If you feel that, because I explained it yesterday itself, I'm just putting it aside. So I'm taking the same example. I'm just starting with this function implementation. So while delete it first. So here, as I mentioned earlier, wait, just a minute, guys. Okay, so sorry guys, I got a call. Sorry. Okay. So as I mentioned earlier, so whenever there is a possibility for change of address in head, at that time we'll be using the address of my head. So address of my head in the sense means where is this address is located. Head's address. I'll be using this head's address so that I can access this head variable and change this value, first value node's address. So that is the reason why we are going to use the address of head. So from my main function, I'll be calling this function as ampersand head, which is nothing but address of my head. So this is how I'll be calling from my main function because there is a possible way. There is not a compulsory way, but there is a possibility that there is a change may occur in my first node. The first node's address can be changed. So that is the only reason why we are using this address of head. So since it is the address of head, so for that, I'm just going to use to get an address, I'll be using this pointer. So inside that address, so that is inside my 100x, inside my 100x, I'll be holding the first node's address, first node's address. So to do that, for accessing that, I'll be having one more address that is going to be next tab. And this 10x, what is this 10x is going to hold? This 10x is going to hold the first node's address. So there is going to be a node's address. And what is the node? That node is a structure node. So now I'm giving the variable name. So variable name can be head address. So for our example, I'm just keeping it as a HA. Guys, please don't use HA. It is just for short form I'm using, but please don't ever use this HA. Okay, better I can use it as a head address itself. So this is the correct way of using it. So what is the variable that I'm going to get? So you should always use a proper valid variable name. Guys, please keep that in mind. I'm keep on repeating it. Please use a proper valid name. Because this is also one criteria that the interviewer will check for you. Whenever he asks you to write a program, he will check whether you are using a valid variable name or not. It's very, very important, guys. Don't think that it is not it is a simple thing. Whenever you start practicing, please use a proper valid name for each variables. Name can be of any size, but please use a proper valid name. Okay, sir. So that's it, sir. So this is my function. So then I'm going to check with the same initial condition. If my value inside my head address is equal to null, which says that there is no list is there, so I can't able to delete it. No? List is empty. Else, if else if I have only one node in my list. Else if I have only one node in my list. That is, if I have only one node, that is, I have only 10x is available in my node. There is no other node available there. Then at that time, my head value should be changed to null. So to check that condition, I'm using this. Okay, maybe I can use another one variable. You can use another one variable to get the value of head. So start node var temp. So this temp is going to hold the value of my head. That is value inside that head address. And also I'm going to use another one variable. Right now that this variable is not required. So I hope this is fine. So what I'm going to do is I'm just going to check whether there is only one node in my list. So whether there's only one node in the list, in the sense, the next node's address will always be null. So for example, it is like this. So this is the first example. And this is going to be my second example. In my second example, what I'm just giving is, so 100x is the address of my head. So head holds a value of 10x. So inside the 10x, I have only one value, that is the only list I have, and there is no more list is there. So if this is the reason, if this is the case, then what I have to do? I have to change the head value. So if I want to delete this node, then what will happen? If I have deleted this node, then what is the value that will be inside my head? Guys, I'm audible. Is my voice is clear? Yes, none. None. So that is the scenario that I'm checking here. That is the scenario I'm checking here. So how I'm going to check this? I'm using this. Either I can use this address of my head address, sorry, the value inside my head address, or I can save that value inside a temporary value. And by using that temp, I can check it. So now I'm checking it, whether my temp of next is equal to none. It states that there is only one node available in my list and there is no more node in the list. So what I'm going to do is I'm just changing the head value. Star of head address equal to none. Else what it says, else there is so much of nodes there. There are many nodes available. So that what I have to do, I have to remove the first node. So there is nothing but if I want to delete at the beginning, then I'll be removing the first node. Then if I'm removing the first node, then what is the value that has to be updated to my head? Sure, the first node is going to be 10x and the second node is going to be 20x. If I'm going to remove the first node 10x, then what is the value that will be updated to my head? 20x. So how can I take the 20x? Where is the 20x? This 20x is present inside my 10x, and I have access variable to access this 10x. So how I can access it? So by using this value, that is star of head address is equal to temp of next. See, as you can see, I have changed all the values directly inside my head. I'm not assigning the value to my temp. You can see this. If I have assigned it to a temp, what will happen? So instead of using this star of head address, if I use it as a temp, then what would happen? What would have happened? Okay, so maybe I can reduce the number of lines because it's taking too much of spaces. Sir, I have substituted with the temp value, sir. So because star head address is also going to represent the same temp value. Sir, why sir then why do I want to use star of head address? I can directly use temp. You may get a question like this. Yes. So no other person has got that question like that. Sir, why sir I want to use it as a head address? Then why do I want to use this temp? Okay, maybe I can explain it clearly. So right now we can start with here. So we have this variable head. Both are same. No, actually both are not same. So head is inside my main function. So that is going to hold the starting address. Yes. Deleting at first, so the head address should be changed. Yes, correct. Because this head value is inside my main function. Okay, sir. Now what I'm going to do is I'm just calling this delete function with the address of my head. So with the address of my head. So in this example, I'm using this 100x as my address of my head. So here what happens is I'm passing the value 100x to my function delete at the beginning. This 100x in the sense it refers to the direct variable head that is present inside my main function. I can directly access this head value from any function by using this reference variable. Yes. So now this 100x is passed as a variable to my head function. So now I'm getting a function or I'm creating a variable. This variable is going to get the value as 100x. This variable is inside my deleted first function. Right, up to this is everyone is clear? Up to this is everyone is clear? Up to this is everyone is clear? Yes. Okay, sir. So now I'm going to into my function. So now what I'm going to do is I'm just going to create a temporary variable. So for my temporary variable, I'm taking the value. So what is the value I'm taking here? I'm taking the value inside that head address. So my head address has a value of 100x. So what is the value that is present inside my 100x? So if I put a star before my address, that states that the value inside this 100x. So inside that 100x, what is that value I'm having here? 10x. So my temp will hold the value of 10x. Okay, so now I have initialized the variables. So I have completed the variables. So now I'm going into my function, circle condition. So now I'm taking it. I'm checking, sir, whether a list is available or not. Whether list is available or not. Yes, I can directly use temp here. I can just the checking condition. So this I don't want to use this head address, but it's up to you. You can use either star of head address or you can use temp. That is up to you. That is up to you. So now I'm taking the condition. So what is this head address? The head address is going to be hold value of 100x. Head address is going to hold a value of 100x, and I'm adding a star before 100x. So now this states that the value inside that 100x. So the value inside that 100x is the value inside that 100x is 10x. I'm checking with the condition whether 10x is equal to null. So whether 10x is equal to null. Is 10x is equal to null? No, 10x is not equal to null, which states that there is a list there. So my condition becomes false. So I'll be moving back to my next node. So next thing. So next thing is, so here I'm instead of using my head address, I'm just using my temp. So what is the value that is inside my temp? My temp has the value of 10x. And what I'm checking is whether my 10x next part, that is my first node's next part, is equal to null. In the sense, I'm checking whether there is only one node present in my list or not. Yes. So now tell me, so what is this 10x next part? So 10x, so 10x next part is so 10x next part is 20x. I'm checking whether 20x is equal to null. No, 20x is not equal to null, which states that there is a more list available. There is a more number of nodes available. So this list doesn't have only one node. This list does have only one single node. Okay, so that condition will also becomes false. So now I'm going to my last condition. So first I'm changing with them, then I'm using with this head address. So let's see the difference between this. So start with temp and then we can change with this head address. Okay, maybe I can use both the statements here. Yeah, that's next. Okay, sir. Now what I'm doing is I'm just converting or I'm just removing the first node from my list. So the first node's address is present inside my temp. So what I'm going to do is what I'm going to update is so here, what is the head address? What is the head address? Head address is nothing but 100x. What I'm doing here is I'm going to put a value inside that 100x. Sorry. Sorry guys, I don't know. My network has stopped. Okay, it's gaining back. Okay, so is my voice clear now? Is my voice clear now? Yes, yes. So sorry, there is some network glitches my side. Sorry. I'm closing the unwanted things so that we can continue with this. Okay, so yes, you have this 100x. So head address holds a value of 100x. Now what I'm going to do is I'm just going to put the value inside that address. So what value I'm going to put? So here my temp. So what is this temp? What is this temp? So temp is holding 10x. And what is this 10x next part? Is 20x. Yes, correct. So 28. So this 10x next part is 28. So here what I'm going to do is I'm going to assign the value 28 inside the 100x value. Correct? 100x value will be updated as 20x. If I have used this, so what happens is if I use like this, then this will be removed. Directly the node to the next of my list will be linked to my head node. Correct? Do you understand this? Do you guys understand this? Okay, so the next statement. So, guys, I'm audible. Is my voice is clear? Can you able to understand this? Want any response from you guys? Yes. 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 Thank you. Yes. So now I'm thinking with the same condition, sir. As you mentioned, sir, to start with, okay. So someone has unmuted himself. Okay, no issues. See, guys, someone is joining with the name as caller. I don't know why it is appearing there like that, but please join with a proper valid name. Because if you are joining with a caller and you are disturbing the session, then that is not a good way of into the session. Okay, that's up to you. You can do whatever you want. Okay, so now next this one. So here, sir, as we mentioned here, star of negative is always going to be 10. So I'm just saving the value as 10. So now if I use this here, so temp of next is going to be 10x, 10x next part. So 10x next part is going to be 28. So what I'm going to do is I'm just going to save the value inside my 10. Now, where this value will be updated? This 20x will be updated at where? Either only in 10 or it will be updated in head address. Will it be updated in head? See, I'm not using this statement. I'm not asking about this statement. I'm not asking this statement. Just skip this statement. If I'm not doing this, I'm just doing only this. If my temp is equal to temp of next, then this will update only inside the temp. The temp is inside my function deleted first. And this value will not be updated in my main function. So main function's head will never be updated from 10x to 20x. Correct? Can you guys understand this? The difference between star of head address and temp. So that is the reason why we are using this star of head address mostly. Correct? So okay, we don't want this temp. Actually, we don't want this temp variable. So there's an extra variable that, but for your understanding, I want to tell you this. Because then only you can understand it clearly. If you use this, what happens? If I not use this, what will happen? So that is the way that we have to learn. So now what happens is, now this statement is, I'm just commenting this statement, so this is not required for us. So whatever changes that we are going to do, whenever we are going for deletion or insertion at the first node, only for the first node. If a deletion is going to occur in my first node, or if the insertion is going to occur in my first node. At that time alone, we have to assign the value directly to my head address. Yes, guys, do you understand this point clearly? Whenever there is a deletion of node in my first node, and whenever there is an insertion of node in my first node, and for these both scenarios, we have to update the value directly inside my head address. That is directly inside my head, and that head should be present inside my main function. Do you guys clear with this? So now at this point, this head will be updated as 28. Is this clear, guys? Can you able to understand this? Delete it first. No. No, ampersand head address is again a variable that will not work correctly. See, head address is going to be a variable that is going to be present only inside my delete function. Deleted first. So this is a deleted function, and this deleted function is the one who's going to hold this head address. This main function doesn't know what is my head address. Yes, Praveen, I hope you can catch my point. We can have to directly access the head's address only. There's no other way. There's no other possible way. So if I want to do changes in this head value that is inside my main function, a head that is present inside my function, then if I want to update this head value, then there is no other way. We have to access this head's address. There's no other possible way that we can access this. Because without this address, we cannot access this memory allocation. Without that memory, we cannot change the value. Yes, guys. Good. Okay, I hope this is clear for you all. Can you move to next function? Or can I complete this function? So because right now we are deleting only first node. Yes. That will give an error. So for here, what we have to do is we have to use the same headers. Yes, because I have removed the 10, so that will throw an error. So instead of using that, I have to directly use the star of head address of next. Yes, this. So any more doubts on this? Delete it first. Guys, any more doubts on that? If you have any doubts, you can ask me. Or else we can move to the next function, next method. Yes, you have to change it everywhere. Okay, so how to refer head by another variable using head address? Then we have to use another one more variable. That's it. because head address is one variable. With that, we can access the address of my head. If I don't want to use head address, then I have to create another one more variable, and which should be passed from my main function. So if I want to use another one more variable, then I have to pass the head address from head. Again, I have to send it as a head, and here I have to use another one more variable, the same like that. Like that, you can access it. There is no other way. See, only the reason we are using head address is only to update a value inside my head. And when I'm going to update this, only when I'm going to change the first node. No, it is not only in parameters. There is one more way is there. That is, we can send back this address to here. We can return back. We can return back this address here. Like whenever I'm going to change the value, I can change it here. So there is structure node stack, which says that I'm going to update the value. So here I delete that first. I can keep it as head equal to deleted first. So the value which is going to be returned from my deleted function, then that value can be directly assigned to the head variable that is inside my main function. So this is also one way if I'm not going to use the parameters. Yes, guys. So okay, so now I'm moving to my next function. I hope that is clear for everyone. Still any more doubts? Guys, I suggest you if you have any doubts, please post it and post it to everyone so that others can also understand your questions and so that I can explain them the scenario here. Yes, the question should be see, if you want to tell something, you can tell me in a private chat. But if you have any questions, doubts, please post it to everyone so that your friends can also understand what is the question that you are asking. Yes, so that I can explain the solution again, so that they will also understand what is the question that you thought of and what is the solution that I'm telling them. Yes. Okay, so now I'm going for my second function. So delete at last. And I have so many have posted your solutions in discussion forum, and mostly I've seen that many didn't use this previous pointer. Because previous is very important pointer whenever I'm going to delete a node. So previous is very much important. So because since there is going to be a head node, we don't want that any previous node because it is going to be the starting point. So at that time we don't want any previous nodes. But for rest all the scenarios, we need the previous pointer. So whenever you are deleting it, please make sure you are using a previous node. Or else you have any other possible way to access the previous node. Because yesterday I've seen up to 6 or 7 responses, and only one, I think so, one or two, one person or 2 person have used this previous. The rest of didn't use this previous function. Sorry, guys. Okay. So right now there is no previous node there. So I'm just keeping it as a null. I mean, checking my initial condition. So the same condition, if there is only one node present in my list. So yes, I have to traverse to my last node. Yes. So how can I traverse to my last node? I have to traverse till my last node. So then how can I traverse to my last node? The same loop that we explained in the previous session. While my temp of next is not equal to null, I'll be traversing. So temp equal to temp of next. So this will give me the last node's address. Yes. So, but here only one thing that we require. So, for example, I'm just taking an example here. So head address is going to be 100x. So inside that head, I have the value as 10x. So 10 and 20x, 20 and 30x, 30 and none. So if I want to delete this last node, so the function which I'm going to write is going to be a delete at last. So which is nothing but I want to delete this last node. So if I use this iteration, that is my temp of next equal to null, sorry, my temp of next is not equal to null, then this temp will hold the last node's address. Correct? So I have explained this loop, what is happening here, and what will happen when this condition is given, and what is the value this temp will hold. Can you guys able to recall that? Yes. So this temp will hold the last node's address. But actually, what we have to do, we have to remove the last node. So this last node's address is present in which node? Present to the previous node. Correct. Previous node's next part will hold the last node's address. So I don't want this 10. I want its previous node. So whenever I'm going to my next node, that is, I'm traversing to my next node, before going to that, I'm taking the previous node. That's it. So at the end of my loop, at this end of my loop, this previous node will hold the node to be deleted previous value. So what I have to do, I have to update the previous nodes next to none. That's it. Maybe I can explain it clearly if we start to iterate it. So that is the function. Yes, so yes, Karthikeyan has used that. Yes, I have seen that Karthikeyan, but that condition will not be satisfied for all. Temp of next is not equal to null. That will be accepted for some scenarios, but for some scenarios it will not be accepted. But you can use it. But you can use it. There is no restriction to use it. You can use it. You will be using it in the later problems. You'll be using the same example, the temp of next of next. For upcoming problems, we'll be using these types of scenarios. But for deletion, it is. I hope that is not required because that will not satisfy all the reasons, all the scenarios. Okay, so now back to this implementation part. So here, from the main function, I'm setting the address of my head. So my head address value will be passed to head address variable. So my head is holding the value. So that is holding the value of 10x, and head address is going to hold the value of 100x. So apart from head address, I'm going to create two more variables. One is temporary, another one is my previous value. So temp is going to hold the head's value. So temp is equal to star of head address. Correct? So here the head address is going to be 100x. So what is the value inside my 100x? The value inside my 100x is going to be 10x. So 10x is nothing but my first node's value. Correct? Or the first node's value. That is the value that will be stored in my temp. And right now, there is no previous node available because here is the first node. There is no more previous node is there. So what I'm doing is I'm just keeping this previous as null. Yes, I have just declared all the variables and also assigned the values for each variables. Is it clear? I have completed up to this. Is this clear for all? Is this clear? Yes. So any doubts in that? No, sir. So now the task is going to start. So what we have to do? We have to remove the last node. So remove the last node. So what I'm going to do is I'm just starting to iterate it. So first I'm checking whether the list is available or not. First condition first. So I'm checking whether the list is available or not. Yes. So head address shows the value of 100x. So the value inside my 100x. So what is the value inside my 100x? 100x value. The value inside my 100x is going to be 10x. Correct? So the value inside my 100x is going to be 10x. I'm checking the condition whether 10x is equal to null or not. So whether 10x is equal to null. No, 10x is not equal to null, which says that a list is there, so I can delete it. So I'm moving to my next condition. So next condition, I'm checking whether there is only one node present in my list. So there is only one node present in my list. So if that is the case, then that is the last node. If I have only one node in my list, then that is the last node in my list. So I have to delete that node also. So I'm using the same condition here. So I'm checking whether 100x next part. So 100x next part is equal to null or not. So what is this 100x next part? Okay, first 100x. What is this 100x? 100x is nothing but my address of my head. The value inside that 100x is going to be so star of 100x. What is the meaning for it? The value inside this 100x. Value inside this 100x. So value inside this 100x is nothing but my 10x. So 10x next part. Who's my 10x next part? 10x. So 10x next part. Who's my 10x next part? Who's my 10x next part? So next part is going to be 20. Correct? So which states that there is one more node there. So this is not the last node. So I don't want to delete it. Correct? So now the 20 is equal to null. Condition becomes false. So I cannot delete it. Correct? So now I'm moving to my next condition. This condition becomes false, and this condition is also become false. So now I'm moving to my else part. So now the loop starts. So now here is where the loop starts. So now I have to traverse to my last node. So whenever I'm going to traverse to my last node, I have to take the previous node's value. So first here the temp is going to be starting from my first node. So temp holds the value of 10x. So I'm checking whether 10x next part is null. Whether 10x next part is not equal to null. So here 10x next part is 20x. So 20x is not equal to null, which states that there is a next node available, then I have to traverse to my next node. Correct? Yes, guys, can you understand that? The same condition. Yes. So now what happens is, so now I'm taking here. So now this condition becomes true. So now whenever it comes true, now I'm going to execute the statement. So till now there is no value assigned for my previous node. So whenever this condition is true, then I'll be iterating directly to my next node. Correct? So I'll be iterating directly to my next node. There is nothing but I'll be updating this 10x with 10x next part. So 10x next part is going to be 20 years. Correct. So I will not be updating like that. Just a minute. I'll be reducing this font size. Is this visible, guys? Is my text is visible? Because I reduce the font size, is this visible or do I have to zoom it back? So because yes, okay, thank you. Okay, so this is the first time I'm going to assign the value for my previous node because so here what I'm going to do is I'm going to move from first node to second node. So before moving to my next node, what I'm going to do is I'm taking this first node's address as my previous node. So that is the only thing I'm doing here. So here the previous node, what is the value that is present inside my temp? My temp holds the value of 10x. So now the previous will be updated as 10x. This is the first time previous value will be updated here. After updating the previous value, then I'll be updating the temp. Yes. So now the temp will be updated as 10x next part. So 10x next part is nothing but 20x. So now this previous will hold the value of 10x and temp will hold the value of 10x next part. So 10x next part is nothing but 20x. Correct? Do you guys understand this? Guys, can you able to understand this? Previous and next. Previous and temp of next. Is it clear? Yes. Again, loop has been updated. So now the calculation has taken place. Now again my loop will start. So now the temp holds the value of 28. So 28 next part. So who's my 28 next part? 28 next part is 38. Correct. So now I'm checking with this condition whether 28 next part that is going to be 38 is not equal to null or not. Yes, 38 is not equal to null, which states that there is next node available. So I have to move to my next node. So before going to my next node, what I'm going to take is I'm just going to take the previous node. So what is the previous node? My temp holds a value of 28. So I'm saving the same 28 as my previous node. After updating the previous value, I'll be moving to the next node. My temp will be updated to 38. So now the previous will hold the value of 28 and my temp will hold the value of 30x. There is 20x next part. So 20x next part is nothing but 30x. Correct? So if you can visually see it, correct? Because who is the previous node for 30x? Who is the previous node for 30x? Previous node for 30x is 20x. So the same thing I'm taking in a variable. That's it. Yes, it's very easy, very simple. So now, so again, temp has been updated. So now I'm going for my condition. So now I'm going for my condition. Where my temp of next? That is 30x next part. So who is my 30x next part? 30x next part is null, which states that we have reached the last node. We have reached the last node, and that is the node that we have to delete it. Correct? That is the node that we have to delete it. So now what I have to do? We have reached the last node. So now the temp holds the last node's address, the node to be deleted. Temp is holding the last node's deleted. Sorry, node to be deleted. And where is this value is present? It is present inside my previous node's next part. So what I have to do? I have to change this previous node next to null. Correct? So if I'm changing the previous nodes next to null, then the loop will, sorry, the link will be broke, and this node will be separated. Correct? Yes, guys. So that is the only step that we are going to do here. So whenever the loop terminates, which states that I have reached my end of my list or I have reached my last node, and this previous has the last node's previous node's address. So now after this loop terminates, what I have to do? Just I have to update the previous node's next part. So previous node's next part. So what is the previous node? Previous node is 28. So 28 next part should be updated as none. So now what happens? This node is separated from my list. Correct? I have removed that node from my list. The data will be there in my memory. It will not be deleted. If I want to free that memory, then I have to free that by using. So one person has used this function. So free of 10. So this is the actual way that you have to remove that memory or delete the memory. Or one of your friend has used this method. Free of 10. He has used it in his discussion forum. You can go and check it. Is this? So is this clear? Is this clear? That is the last. Is this clear? Any doubts in it? Yes, free of temp is an optional. It is an optional. It is not mandatory. It is an optional. If you are working in a real-time application, then that is a compulsory thing. That you are working in an organization and you are going to create an application, then whenever you are going to delete it, then you should use this free of function. That is compulsory part. But here it is just for our practice. So here we are not going to make it as a compulsory thing. Yes, yes, that is the proper way of coding convention. Yes. See, actually, why I'm not using this is right now we are practicing more on online compilers. We are not going to use for our offline compilers, or we are not going to work on application. So this memory management is will be taken care by that application. The application which you are going to use, either a Skillnet or Edmatrix or any online DDB or Replit or any platform, all these memory management will be taken care by that platform. So that is the reason I'm not using this AF function. Yes, yes, Dhanush. Do you understand my point? But you have to, if you want, you can use it. There's no wrong in it. But that is the correct way of actual coding conversion. So you have to use this tree of 10 to remove that node. That is the proper way. But as I said, this was taken care by the compilers that is built inside the online compilers. So we don't want to do this function extra. It will be automatically deleted. So that is the reason I'm not using here. But if you want, you can add it here. Yes, guys. So any more doubts on it? I hope it is clear. Is that clear? Yeah. Super, sir. Okay, sir. So now I want you all to open your rate matrix. Open your rate matrix platform. Is open your data structure course. So log into your data structure course. Inside that, you'll be having this linked list module. Just open that linked list. And I hope all the functions that we discussed from the morning is there. Delete at beginning, delete at end, add at beginning, append, and count is very easy. Maybe I can explain this count because this function is already explained. This is also explained. And that particular question is also explained. So I want to explain you search, count, and one more function is delete any element. So these are functions that I have to explain. So right now I'm starting with this count. I want you guys to upload your codes here. I hope everyone know how to work in it. I hope everyone is clear how to work on it. Just I'm switching my role to student. Okay, so this guy will be able to see this. So when you come inside, just open the problem, just click on that name. It will open the problem statement. So they'll be explaining you what is that they want. So this is a question that they have given. So linked list count. So what is the thing that they asked? So write the C program. See guys, if you have any login issues, you can ping me later, or you can ping me to Gayatri ma'am. So we can help you to solve the login issues. So if you have moved out of the session, please come back and join here. Just I'm going to use this and I'm going to try to explain that problem, how to solve and how to do it. Yes, guys. So this is the first problem. Okay, so write a C program to count the number of nodes in my list. So yesterday we had a discussion, get length function. That is a function that he wants us to write. So he wants to count the number of nodes in my list. Yes. So he has also given a structure node. So structure node capital N. So int data structure node star next. And also he has given some input examples. So enter the number of nodes is going to be 4, and I'm going to get the 4 nodes, and the elements in the linked list are. I'm just going to display the list and also the number of elements in the linked list. So we have also given a function prototype. So these are the function prototype that you have to use. That is, you have to use only append with structure node double star that is going to be head address, and another one is the value to be inserted that is going to be in. Similarly, display, which is going to display the list, and also count. Yes, count will always start from 1, I think so. Yes, 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 yes. Okay, so yes, Dhanush, I hope you have reached the solution. I thought that you are asking me a question. Okay, so right now I'm going to, yes, they have given all the prototypes here. Just we are going to implement this function. So yes, so he asks us to create the structure node here. So what we are going to do is, so we are going to do this structure node. So int data structure node star next. So this is the node structure that was given, and inside my main function, I have to call this count function and also this display function and also this append function. Apart from that, he also given me a one variable. So he first initially he's giving me n value, and based on that n value, I'm going to get the values from the user and I'm going to get it. So it is, in a sense, he's making us be easy to implement it. Okay, so before that, I'm just creating a template function. Structure node star create node. Guys, if you want, you can listen, understand it, then you can implement it. So this I'm going to implement the same function here, which I have explained you in the previous sessions. Yes, yes, Sriram. Yes, Sriram has got the solution. You can directly post a solution to everyone, Sriram. So your friend Sriram has come up with a solution. Yes, I'm implementing this function. That's it. And then new node of data. That is going to be the data that is given by the user. And new node of next, that is going to be null. After that, I'm just going to return a new node. So this will be written back to the previous user. Okay, guys, if my screen is visible, if my text is clear, is it visible? Is everything is clear? Yes. Yes, 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 yes. Thank you. Okay, now I'm going to implement this append function. So here he has given us q, so I'm changing it as a head address, and he has given the variable name as num. So I'm just, for my understanding, I'm changing it to data part. So you can give this as a head address. Sorry. So head address. So whatever the variable name that you want to use, you can use it. Either HA or whatever. So for easy convenience, right now I'm using, but please don't use this. Please don't use this. Please use head address completely. So structure node star new node. So this is equal to create node of data. So after this, I'm just going to create another one more node. So there is going to be a temporary variable which is going to hold the starting address. That is going to be star of head address. And after that, I'm going to check whether list is already there or not. So for star of head address is equal to null. If it is null, it's just the append function that we normally use. Star of head address equal to new node. Else I have to traverse to my last node. So else I have to traverse to my last node. So guys, uh, maybe I can give you some tweaks in it. So why sir I do why sir I want to keep on using this while loop to identify my last node because it's going to be an append function. So why don't I use another one variable which is going to hold the last node's address? Structure node start last. Till now there is no last node. So I'm keeping it as null. Or else yes. I can keep an extra variable like this last, and whenever the first node is inserted, and that node is going to be my last node. So I'll keep track of it. But whether this will work for all? No, this will not work for all. Okay, I will just check this once more time and then I will tell you back. Because there's one more option like this. We can use a last variable. This last variable will hold the last node's address. But the only problem is in this session, we are going to get each and every node one time. So that in this scenario, this will not work. Okay, I will set in a different scenario. While my temp of next is not equal to null. Temp equal to temp of next. So whenever I use my last node, then updating my last node to new node. So there's a normal append function. So we can use this last variable, but I will be explaining in the next session or upcoming sessions because that will be very easy for you to reduce this loop. There is a possible way to reduce this loop, and that loop can be reduced by this variable last. Maybe I can explain it in the session, upcoming sessions. Yes, so coming back to my main function. So inside my main function, what I'm going to do is I'm just going to call this scanf %d. I'm getting how many values the user is going to get. After that, I'm using the iteration equal to I less than and I plus plus. So for each iteration, I'm going to get the value from the user. So scanf %d, comma ampersand data. So for that, I need a variable data. So for that, I'm going to create a variable data. So after getting the data, what I have to do? I have to call this function append. So append or so ampersand head, comma data to be passed. So till now I didn't create any head. So this will throw an error. So for that, I'm going to create a head value. Structure node start head. So till now that list has not formed. So I'm keeping this head value as null. So this will append the value to my list. So after appending, what is tells? So see, I hope you can see the question. So we have entered the number of nodes. Okay, before getting n, I have to give a statement. The print of after that I'm getting the n, and after that I'm getting all the values. And whenever I'm getting the value, I'm just inserting it. After that, I have to call the display function. And before the display, the elements in the linked list should be printed. Okay, so before calling that function, I'm going to complete the display function. So display function, which doesn't have anything, so just I'm keeping this as a temp. So here, yes, temp equal to null, and I don't want to do anything, just I'll be returning back. So because he doesn't give me any statement to print, then this is empty or not. So I'm just returning back. So else I have to traverse to all the nodes, while my temp is not equal to null. And then I have to print all the nodes. So printf %d, comma. So temp of data to be printed. After that, I have to traverse to my next node. So temp equal to temp of next. So there's a normal while loop. So after this, you also use this null value to state that so this is the end of my list. So I've given the same thing here. So temp equal to temp of next. Yes, this display function will work. So now I'm going to call this display function from my main function. So before calling this function, he told me that the elements in the linked list are. He wants me to print that. So printf elements in the linked list are. So it's not going for a new line. So I'm just giving a space here. After that, I'm calling this function display or head. This will display the head, or this will display all the nodes in my head. Okay, so after displaying it, what he wants us to count the total number of elements in my linked list. Guys, I hope you can follow me. Are you guys with me? Are you guys with me? Are you guys following me? Yes, guys. So make sure you're understanding the question properly. Without understanding it, we cannot type this code. Yes. Make sure you're understanding each and every word that has been given in this. So what are the things that he has given, and what is the thing that he's giving us, and what is the thing that he wants us to use? Everything should be understood clearly. Without this, we cannot do this. So that is the reason I'm explaining in each and every line, and I'm explaining it in detail. Yes, it is very, very important, guys. Please make sure that. Okay, now I'm going for my count function. So as a friend suggested, he already has. So yes, in my count, I'm not going to insert, I'm not going to delete. So there is no updation is going to take. So I don't want to use the head charges. So that is the reason he has given only single star. That is the reason he has given only single star. Correct? So I'm using the variable name as 10. Okay. The same condition here. If my temp is equal to that says that there is no list, then see what is the return type for this function? What is the return type for this count function? What is the return type for this count function? Int. So what is the int should be returned back? Total number of nodes present inside the list. Correct? Total number of nodes. Yes, correct. Count of nodes. So for that, I'm keeping the variable count. You can keep a variable or you can directly send it. That's up to you. If you want to use a variable, you can use it. If you say, I don't want to use variable, so I can directly count it and I can send it, then that's up to you. So, but for our understanding, I'm keeping the variable as count. So if there is no list is there, then what is the count of my node? So in my list, there is no node available. In the sense, my list is empty. So what is the total number of count of my list? Count of my nodes? 0. So I have to return this 0 back. So here I'm returning my count. Yes, yes, I have to count each and every time. So for that we have the loop while my temp is not equal to null, I'll be traversing till my null, and for each node I'm going to visit. So here I'm going to increment my count. Yes, after incrementing my count, I have to traverse to my next node. So it is temp equal to temp of next. Correct? Is that correct? So in the previous example for display, what we did is in this operation part, we have just used a function called printer to print the data. But here I'm not going to print it. Here I'm just going to count the number of nodes. Maybe you can see this difference here. So this is my print function. The operation part is just taking only one line to print the value. But here I'm just going to count the value. Yes. Just I'm going to use a one statement that is going to be count, and after that I'm incrementing the node. I'm incrementing the node. Is that clear, guys? Can you able to relate it both? So this is the operation part that we are going to do. This is the same operation part. The rest all the codes are going to be same. Yes or no? The rest of all the codes is going to be same. Only the operation line is going to be changed. Is that clear, guys? So at this end of loop, I'll be counting all the nodes and that count will be stored in this count variable. So after coming out of my loop, I'll be just returning the count. That's it. This will return my count to my previous function. So in my main function, I have to use this. So here I need a variable to get the count. So for that, I'm using another one more variable. So int count equal to 0. So here before getting this or calling this count function, I'm just going to print the number of elements in the linked list is %d. I can directly use it here, or I can directly use like this. So count. Okay, count is this function name. Yes, count is a function name, so I cannot use the variable name as count. So I'm keeping it as C. C equal to count of it. Either I can directly use it with a variable, or I can directly give it here itself. %d, comma, C. Either I can use like this, or I can directly use it like this. Count of it, so that I can reduce the variable. I can directly use, or I can directly call the function from this my printf function. Either I can use it, or I can store the value in a different variable and I can access it. But this is not required for right now, for this example, because we can reduce this number of variables, because that will take too much of time, or that will take extra memory spaces. So after doing that, I'm just saving the value, saving the function. After saving, I'm just going to execute it. If there is any error, the compilation error will occur here. So there is no errors. So it is asking us to enter the data, number of nodes to be inserted. So I'm just giving it as 4 nodes. So after that, I'm giving the value to be inserted. Okay, only 40 is fine. Okay. Sorry. Yes, the elements in the linked list are 10, 20, 30. Sorry, I have removed that 0 when I'm giving a backspace. I have removed that 0, so it has removed. And the number of elements in the linked list are 4. I hope is this clear, guys. Can you able to understand that? Okay, these are some warnings that I have got. So it's not an error, it's a warning. Implicit declaration of function append. It states that I have used an append function, but this append is not inside my main, or is not declared inside my main. So what I have to do, I have to just put that function above my main function. That's it. By using that, I can reduce these warnings above my main function. I have to use it. Okay, so maybe this will reduce all the warnings. Yes, guys. So is it clear? Yes, yes, function prototype. Function prototype is also fine. We can also do the function prototype. So that will also reduce these warnings. Either I have to declare or initialize all the functions before my main function, or I can give the prototype for my functions before my main function, so that it will reduce these warnings. Correct. I'm just executing it one more time. I'm checking whether this errors are occurring or not. Okay, get execution servers. Yes. Okay, so I'm just going to give 2 nodes. Okay, guys, I hope my net connection is a little bit slow, so that is taking too much of time. Okay, just I'm closing. Okay, this time I didn't get any warnings, so I hope you can see that. There's no warnings here. Yes. Two nodes, one is 10, another one is 20. That's it. The elements in the linked list are 10 and 20. And after that, there's no node that is represented as null. The elements in the linked list are 2. And I hope you can see this. There is no compilation errors here. So after that, what you have to do is you have to submit this. So evaluate, submit for evaluation. So please keep that in mind, guys. This you have to execute and then submit for evaluation. You have to evaluate it. So once you are evaluating, you will be getting. So how many test cases has been passed? So there are total 3 cases, and all the 3 cases has been passed. You'll be getting a solution like this, and you'll be getting a grade like this. Once you get 100%, then that only states that your problem is accepted. Else, it will not accept it. Yes, is this clear, guys? Can you able to understand this? Yes, yes. Okay. So this is our task today. So today afternoon, I want everyone to complete all these functions in this Edmatrix platform. So now it is time 1:15. So after this lunch break, so take 1 hour time. So 2:15, join back, and I want everyone to start working on this linked list module, and I want everyone to complete all these problems. I want everyone to complete all these problems. If you have any difficult problems, like, sir, delete that any element, I feel it's a little bit difficult, then I can explain you. I'll be helping you. But delete at beginning and delete at the end is everything is completed. And search is also very pretty much easy. Particular position is also easy. Yes. After a particular question is also easy, append is also easy. Everything is discussed already. So I want you all to start solving all these problems by this afternoon session. By 2 p.m., sorry, 2:15, you have to join that. So you have to start working on this module. Is it clear, guys? Is it clear, guys? So your task for your afternoon has been scheduled. Yes, you have to join to the meeting and you have to start working on this module. Yes. Okay. If you have any doubts, you can ask me now. Okay, so let's have a new topic today. So what topic can we add in discussion forum? Can we add search function? Can we add search function in a discussion forum? Can we add search function? Search function in our discussion forum. Yes, just I want your just the code for my search function. That will be normal. That will be fine for me. So search function. So I'm just adding this discussion forum here. So linked list search. That will be a new thing. So just title, just the operation. So the operation part is nothing but the printf is one operation and count is one operation. Similarly, search is also going to be one operation. So I want you guys to try it out and I want you guys to post your code here. Just the code. Code for linked list search. Maybe that will fine. Yes. So I'll open this discussion forum. I want you guys to post your code. Code alone is fine for me. Just the code. I don't want the working model or nothing. Just the code. Just type your code or just take a photo or just upload your pic, anything. That's up to you. But I want you to post your code here. No, just search function is fine. Search function is fine for me. Search function alone is fine. We don't want the exact main function. That is not the case here. Just the search function alone is enough for me. But what I'm expecting is I want you to understand the function clearly and then you have to post your solution. That is the only thing that I want. If you are writing your code, then you should know what you are writing. If you are using a variable, then you should know why you are using that variable. If you are using a loop, then you should know why you are using that loop. That is the only point that I'm expecting from you. Whatever thing that you are writing or posting, that you should know aware why you have used that. Yes, guys. Yes. Any doubts? So today's discussion forum was linked list search. I'm expecting a solution from you all, guys. You can post it at any time. So today I'll be seeing. So how many of you are trying and putting it? Yes. Yes. Yes, guys. So thank you all. So thanks for joining the session. So we'll meet up in the afternoon.